Today we are going to solve equations with rational exponents. So rational exponents being, they could have an exponent of 2, they could have an exponent of 3 over 2, so a fraction where the numerator and denominator are integers. It could have a exponent of 4 over 5. So that's what we will be doing today. I want you guys to complete the do now, which is 1 through 4. Do 1 and 2, really look at how you did 1 and especially 2, and then try and reason how to do 3 and 4. So pause the video, take 4 to 8 minutes, it's a little bit longer, and complete the do now, and start it back when you're done. So number 1, it is the square root of 2x plus 8 equal 2x plus 3 equals 8. The square root is alone on the left side of the equation. So it's what we did yesterday. To get rid of that square root, once it's all by itself, we want to square both sides. And we would get 2x plus 3 after the square root and square cancel equal 8 squared, which is 64. Subtract 3 on both sides, and we're just going to solve it like a normal equation now. 2x equals 61. Divide by 2, divide by 2. X equals 61 over 2, which is 30.5. Don't circle that yet because we have to check it. We always need to check radical equations because it could be an extraneous solution. So we're going to check over here. And I'm just going to plug in my value of x, which is 30.5, in for x in our original equation. Has to be the original equation. Can't be any other equation. Okay, so we then get the square root of 64 equals 8, and square root of 64 is 8, so that checks out. That is an answer. Number 2, so you could go about and say, oh, when I raise something to the 1/2 power, I know that's the square root of whatever is inside, which you're 100% correct. That's a very easy way of doing this question. And then if you take a look at it, now we have the same exact equation here as we did in number 1. So we can solve it just like we did in number 1, and we would get our answer of 30.5. But I want to show you guys a different, very slightly different way of doing this problem. It's just a different way of thinking about it because it's going to help when we solve an equation with any rational exponent, not just 1 over 2. So instead of doing that first, I'm going to rewrite it so it's a little bit larger. So 2x plus 3 to the 1/2 is equal to 8. So what I'm going to do, and it's going to surround the logic of if I multiply 1/2, which is our exponent, we are trying to cancel that out to get the x by itself. If I multiply that by the reciprocal of it, the multiplicative inverse, I get 2 over 2, which is 1. And anything to the first power is just whatever it was. That exponent goes away. So I'm going to multiply, or I should say I'm going to raise both sides of the equation to the second power, or you can think of it as 2 over 1 if you want to, just to show that it's the reciprocal. So when I do that, what happens is we are left with 2x plus 3, and then power to a power, we have the 1/2 to the 2, or 2 over 1. You multiply the exponent, so 1/2 times 2 is just 1, equals 8 to the second power. And anything to the first power is just whatever is being raised to the first power. We don't have to write that first power. So it would be 2x plus 3 equals 8 squared, which is 64. And we do the same thing from here, solve, and you should get x is equal to 30.5. I know it's the same equation, but just because we're in the habit of it, just make sure you check it. So that would be 2 times 30.5 plus 3 to the 1/2 equals 8. And you end up getting 64 to the 1/2 equals 8. And 64 to the 1/2 is just the square root of 64, which is 8. 8 equals 8. So that is going to be our solution, 30.5. So number 3, 2x plus 3 to the 1/3 power equals 8. How are we going to go about solving this? You could try the method from number 1, or you can try the method from number 2. We're going to do both ways. You're going to see that it will get the same answer. So let's do the method 2 from question number 2 first, because that's kind of the newer method. So I'm going to take both sides of the equation, and I'm going to raise each side to the 3rd power. Now, why am I going to do that? Well, that allows us to cancel out the exponent with the x. Notice the left side, everything is being raised to that exponent, so that's what we have to get rid of first. So it's a power to a power. When I multiply 1/3 times 3, or 3 over 1, I'm just getting 2x plus 3 to the 1st power equals 8 to the 3rd. And now, why does 2x plus 3 to the 1st power help us? Well, now we can just drop the exponent and we don't have to deal with that anymore. So it's 2x plus 3 equals 8 to the 3rd power. Feel free to do that in your calculator. Is 512. And we just simplify it from here and solve. So subtract 3 on both sides. You get 2x equals 509. Divide by 2 on both sides, and you would get x equals to 254.5. We're going to check that in a second. I just want to show you guys what else you could have done. So if you did it like the question number 1, what you could have done instead is you could have rewritten 2x plus 3 to the 1/3 power as a radical. So that would be the 3rd root, or the cube root of 2x plus 3 equals 8. And if this way makes more sense to you, go right ahead and do it this way. So then I would cube both sides, and the cube and the cube root cancel out. So I'm left with 2x plus 3 equals 8 to the 3rd power, which is 512. And notice we now have the same equation as we did on the left. So we're just going to solve it the same exact way. We would end up getting x is equal to 254.5. But still, no matter what, you have to always check your work. Check that number to see if it's an extraneous solution. So I'm going to plug that back in to the original equation. Has to be the original equation. So that'll be 2 times 254.5 plus 3 to the 1/3. And that should equal 8. So you can do that math by hand if you want to. I'm going to show you the way I like to check, because it saves time and that allows us to make less mistakes. So you're going to need a TI-84 graphing calculator for this, or really any calculator. I need to get a calculator, Luminos. And what I'm going to do in the calculator is I'm just going to type exactly what's on our left side of the check. So that would be 2 times 254.5, which was our x value. Make sure you close the parentheses. Plus 3, and I'm going to raise it to the alpha y equals to get a fraction. 1/3, I'm writing it exactly how I see it on the page, and then press enter, and what should we get if it is a correct answer? We should get what we said was equal to, which was 8. Press enter, it's equal to 8. This is a solution, so we can circle it. And that is a solution. So I'm just going to erase a little bit so we get more room for question 4. Question number 4. Same equation pretty much, just now a different exponent. It's being raised to the 3/2 power. So If I look at number 4, everything on the left side with the x is being raised to the 3 over 2 power, so that's what we need to deal with first. What are we going to want to do here? Well, we can rewrite it in radical form, but it's a little bit easier just to raise each side to that reciprocal power. So raise it to the 2 over 3. Raise 8 to the 2 over 3. What happens there is the exponents on the left cancel. 3 over 2 times 2 over 3 is equal to 1. So we just have 2x plus 3 on the left side. And then 8 to the 2 over 3, I'm going to write that as a radical if I'm not using my calculator. So that would be the cube root of 8 squared. The cube root of 8, so that'll be 2x plus 3 equals the cube root of 8, which is 2 squared. And 2 squared is 4. And solve it from here, so subtract 3 on both sides. You get 2x is equal to 1. Divide by 2 on both sides. You get x is equal to 1/2, or you can write it as 0.5, 0.5. Oh, I can't circle it yet because I didn't check. So let's check here. Check. Let's plug that in. 2 times 0.5 plus 3, all raised to the 3 over 2, should equal 8. I'm going to go back to the calculator and just check that. So I'm going to plug in the left side into the calculator, and it should be 8 if it is correct and not an extraneous solution. Plug it into the calculator exactly how I wrote it. So that would be 2 times 0.5 plus 3, all being raised to the 3 over 2 power. Press enter, and we should get 8. Ah, we got 8, so it is a correct answer, so we can circle it. So let's go on to the what should I be able to do by the end of today. It's kind of a short lesson. I can solve equations with rational exponents. So we're going to do 2 more, and then we're going to do checkpoint, and then we're done with the lesson for today. It's just practice after that. So number 1. What's a little different about number 1 than we did in the do now? Well, what I'm seeing is we have the rational exponent on the left with the x, but everything's not underneath that rational exponent. Think of it as a radical, because that's what it is. It's the 4th root of x to the 5th. We need to get that by itself first. So, what should I do to get that by itself first? Well, that 1's is not under any radical, so I should add 1 to both sides first. That gets us 3x to the 5 over 4 equals 96. And this is also important to understand. Is that 3 getting raised to the 5 over 4, or is just the x getting raised to the 5 over 4? Well, it's 3 times x to the 5 over 4. If it was the 3 was also getting raised to the 5 over 4, it would look like that. It'd be in parentheses, but it's not. So it's just the x is getting raised to the 5 over 4. So the radical or the exponent on the x, not by itself yet. We have to divide by 3 to further get the x by itself. So that would be x to the 5 over 4. And 96 divided by 3, 32. And now we have the x by itself with the exponent. So what could I do to get rid of that exponent? Well, it's what we have been doing. Raise both sides to the reciprocal power. So the reciprocal power would be 4 over 5. 32 to the 4 over 5. On the left side, it all cancels. We just get x. And then 32 to the 4 over 5. Let me rewrite that with a radical so I can think of it easier. So that'll be the 5th root of 32 to the 4th power. That is the 5th root of 32. 2 times 2 times 2 times 2 times 2 is 32. So that would be 2 to the 4th power. So x equals 16. Don't circle that yet. Let's check it just to make sure. So I'm going to go up here and check. plug in 16 into our original equation, so it'll be 3 times 16 to the 5 over 4 minus 1, and that number should equal 95. When you plug it in and check, you could feel free to plug this one in your calculator and check. You get 95 equals 95. That checks. So x equals 16 is a solution. And number 2, we want to get x alone still. Everything's not getting raised to that 9 over 5 power. That negative 2 on the outside is not, so we want to get that out first. So I'm going to divide both sides by negative 2. And I would get x plus 10 to 9 over 5 is alone on the left equals negative 6. Now look at that left side. We now have the x plus 10 is all being raised to 9 over 5, and that's it on that side. So I'm going to raise both sides to the reciprocal power, which would be to the 5 over 9. Make sure you do it on both sides. That cancels out the exponent on the left, and now we're just left with the x plus 10, so the x is almost by itself, equals negative 6 to the 5 over 9 power. All right, negative 6 to the 5 over 9 power, feel free to do that. It's going to be an irrational number, so I'm just going to leave it as negative 6 to the 5 over 9 because it doesn't tell us to round at all. So now I'm going to subtract 10 on both sides to get the x by itself. And what we get is x is equal to negative 6 to the 5 over 9 minus 10. So that's going to be our answer so far. We just have to plug that into the calculator and check. So when I check, it's going to look like, plug it into the original equation, it'll be negative 2 times negative 6, we have to plug that in for x. I know it's a weird number, to the 5 over 9, plus 10. Oh, excuse me, when we plus 10, our answer was minus 10. And then still inside those parentheses is a plus 10. 9 over 5 equals 12. You can't use the calculator for this. You don't have to. But I'll show you how to plug in the calculator in a second. The minus 10 and plus 10 cancel out, so we're left with negative 2 times negative 6 to the 5 over 9, all to the 9 over 5, equals 12. You would see power to a power. Our exponents cancel, so we're left with negative 2 times negative 6, which is 12 equals 12. So this is a solution. And I will show you how to plug that in the calculator too, just so you guys can see. So I'm going to plug in the left side of this equation. And after I plug it in and I press enter, I should get 12. So let's take a look at it. Important to plug it in exactly how we wrote it. So it would be negative 2. Be very careful with the parentheses. We need a double parenthesis because it would be negative 6 was our answer to the 5 over 9. You can also write it like that. Make sure you get out of the exponent. So I scroll over to get out of the exponent. So I'm not writing everything as an exponent right now. Minus 10. So that was our solution right there. Then we continue the original equation. Plus 10. And everything should be raised to the 9 over 5. I'm going to press over to get out of exponent. That was everything that was on the left side. We should get this equal to 12 when we press enter. It does, so this is a solution, so we can circle our answer. So after this is just a checkpoint, bunch of different solving equations with rational exponents. I want you guys to do 1 through 5. Pause the video, take 5 to 10 minutes, might even take longer, and play the video. Once you're done, we'll go over each of them. Looking at number 1, we have to get the x by itself, so I subtracted 3 first. And then the x was almost by itself. It was just being raised to the 1 over 7th power, so we had to raise it to the 7th power, or you can think about it as the 7 over 1 power. And your correct answer should be x equals -1. When it checked, it worked out. Number 2, everything on the left side was getting raised to the 3/2 power, so we can actually just raise to reciprocal power right off the bat, 2/3. But once you solved, you got x equals 14, which when you checked, did not work out. It was not a solution. It was an extraneous solution. So our answer to number 2 is no solution. Number 3, you could have done this a couple of different ways. What I chose to do first is I chose to make that exponent positive. So I made it 5x plus 7 to the 3/7. I flipped the base. You could have multiplied both sides by -7/3. But that's just going to make a little bit more work down the road. It's going to keep that left side as a fraction. You have to cross multiply. So this is probably the easiest way. And then the check, it worked out. I did not do this by hand. I just plugged in the calculator, and I got 15 equal to 15. And then number 4, I multiplied by 3 on the left and the right side because I canceled out the 3 in the denominator. Then the x minus 1 was all by itself with the 5/2, so I could multiply by the reciprocal exponent, and you would get 21 to the 2/5 plus 1. When you plug it in, it checks. And number 5, solve for a in the following equation. So we have to get a by itself. You first have to subtract f, because then you'll get a plus b is all being raised to c/d, alone on the left side. You want to then raise each side to the reciprocal exponent of c/d, which is d/c. That gets the exponents to cancel on the left, and you're just left with a plus b, and you subtract b on both sides, and then a is all by itself. That's it for today's notes. I want you guys to complete the success criteria, and there's also homework, and that's it.